What we need to do now it is to try to find a set of values of x bar with a sample mean such that the null hypothesis is not going to be rejected. We are going to quote three parameters, n with a sample size. Sample size is given to me as 20. Next, x bar. This is unknown, I'm going to let it be k, and then the population variance. It depends on the information that is given to me by the question. It can be the actual population variance or the unbiased estimate. According to this question, it is given to me that she assumes that the tail length of the squirrels on the island has a standard deviation of 3.8. This is what she assumed based on maybe her experience on the other kind of species of squirrels. That is why this 3.8 that is given to me, it is going to represent for us the population standard deviation. So we do not need to calculate any unbiased estimate. The population standard deviation is going to be assumed to be 3.8. So population variance will be 3.8 squared. Which means that with n that is small, I know I'm going to decide whether it's a z-test or t-test depending on the availability of the population variance. It is available, that is why we are going to choose a z-test for this second part of the question. So let me quote the test statistics. The test statistics is going to be a normal distribution, since we are using a z-test, a normal distribution with the population mean as 14.0, and the variance of x bar is going to be the population variance divided by the sample size, 20. Or if you want, you can also write down this in the standardized form, which is z. That is going to be x bar minus 14.0 divided by square root of 3.8 square over 20, and this will follow a normal distribution of 0, 1. What the question says is that we are not supposed to reject the null hypothesis. So to not reject H0. According to what we have discussed in our topical outline, if you can recall, when we do not want to reject H0, it is when the p-value is bigger than the level of significance. According to this question, we are looking at 5% level of significance, so it must be bigger than 0.05. What we have here is a two-tail test. And what we do not know is x bar, and it can appear in two places. If I were to reference it to the distribution that we are writing down here, the two cases are this. In order for us to analyze a two-tail test, let me just draw the two distributions first. They're actually exactly the same distribution. I'm just trying to represent two scenarios for a different position of x bar or this k. So these are exactly two, these are exactly the same distribution, which is x bar that is going to have a mean of 14.0. It is just that for two cases, one case is when x bar is on the left tail, and the other case is when x bar is on the right tail. So we have to analyze these two cases separately in order for us to find the full set of values of x bar or this k. When it is on the left tail, that means we are interested to look at this area that is on the left hand side of k, and according to what we have discussed in our topical outline, for a left tail, when x bar is on the left tail and applying to a two-tail test that is here, the p-value is calculated by having 2 times of this area, so 2 times the probability that x bar is less than k. So p-value is going to be bigger than 0.05. This is going to help us to deduce one possible set of values for x bar, and according to this, we are going to look at this area that is on the right hand side of k and applying it to a two-tail test, calculating for p-value according to what we have discussed in our topical outline. It is 2 times of the probability of x bar is bigger than k. This is bigger than 0.05. Let's try to calculate k for this. That means probability that x bar is less than k. This is going to be bigger than 0.025. Since this is already less than, it allows me to press the inverse norm in my graphing calculator. So I'm going to make use of this distribution here. When I'm pressing for inverse norm, I'll get k to be bigger than 12.335. Okay, as for this, we need to make some changes. I need to make sure that the inequality sign here is less than before I can press for inverse norm. So this is bigger than k, this is bigger than 0.025. That means 1 minus probability the x bar is less than k. This is bigger than 0.025. So the probability that x bar is less than k, this is going to be less than 0.975. Okay, and again, making use of this distribution, pressing for inverse norm on my graphing calculator, I'll get k to be less than 15.665. So combining these two together is going to give me the range of values for x bar. X bar is going to be between 12.3 okay, and 15.7. Okay, just one more thing to discuss with you over here, okay, because the question asks us to use an algebraic method. Okay, this is something that I struggle a bit, okay, when I come up with a solution for this, because usually when we are asked for the algebraic method, okay, it is to use some algebra, some really algebraic processes to solve for whatever that is unknown. But according to your maths syllabus at this level, the only way for us to solve for the range of values for x bar, okay, it is really to press our calculator, making use of inverse norm and so on, right? Because what we have here is a continuous random variable. So the best possible method that I can think of here, it is really what I've just shown you, okay? So I believe this is the method to solve for part 2 of this question.